So please, if you are having any kind of trouble to open the yesterday projects that I have sent through share file, please just tell me. So here we have our combined model, and this combined model has our geological model and our model for the pit. So if we want to now combine it with our weathering, for instance, we could do that. And if we want also to refine it, we could. I just want to mention the refinements. This is an advanced edition part, but it's also very helpful for us if we want to separate domains within just one lithology. So I will just do an example right here on the geological models. If we use the right button of the mouse on it, we can see that we have here the option New Refined Model. So if we click on that, we can see that we can choose the model that we want to refine. We can choose the lithology that we want to refine, and we can choose another base lithology column if we want and make a new surface resolution. So for instance, we have here already planet, what is the lithology that you have, and just in a pretending case that we are going to check now if it's true or not, but just in a pretending case, we would have the mineralization on the granodiorite. I could just insert the granodiorite on the pit that I have right here on my combined model by editing the colors and just select my granodiorite. So if I wanted, for instance, just have here domained with the higher grades on this domain right here, I would do that by refining my model. So just to mention that we have this option right here to refine our model. So this way we can domain even the lithologies that we have already separated. And now we can go to check a little bit further our data, our numerical data. So just to remember, let's collapse our project tree. We are going to go up high here and collapse all the rows. And after that, we are just going to clean out our scene. So with our scene pretty clear, we can start our day and understand a little bit about the visualizations that we have. So at first, let me just check here on the chat. Everything is good. So now let's expand our drill hole data. So expanding our drill hole data, we are going to get our survey, our essay. Why? We have here two kinds of numbers. So we have in our survey the numbers related to the position of our drill holes. On my survey right here, this is not very oriented, so we don't have that much information from the drill hole. But if we had, we could use this information on our structural trends. In our case right here, we are going to explore a little bit our essays. So we are going to explore here geochemical data. So if you had remember the first step of it, so when we are dealing with numerical data, the first step of it is on the corrections of the errors. And I don't know if you remember this part, so we are just going to take a look again. Here on the essays, we are just going to right click and click on the fix errors. So when we click on the fix errors, we have the invalid values handling. If you remember, we have replaced it. So this way, we don't have any blanks in spaces that we had taken the sample. And why we didn't have input 0 right here? Because 0 means something. So when we are inputting a new or there's no samples from here, this means something. So what we have here from the feedback from our laboratory is that those numbers right here on gold, they were under the limits of detection. This does not mean that it's zero. So when we are replacing it, we are doing that using our instrumental error right here. So we are replacing by the half of the limits, the detection limits right here. So the same we have done with copper. And just remember that if you have non-positive values and infinity values, you will have to take this decision also for those numerical values and also for the missing values if you are doing any kind of geochemical statistical analysis that depends on the spatial distribution of it. So now that we have seen what we are going to do with our data, numerical data, when we first receive it. Now let's just take a look on it. So we are going to take our essays right here and input in our view. So we can check that we have here a bunch of drill holes and they are presenting to us right here the values of gold. If I wanted to see the values of copper right here, how could I do? Let me just expand here the window. So we could come just right here and select copper. And this way we would have the visualization of the column copper that we have inserted right here on our essays. So if we want to bring more data, if for instance, I have realized that I just don't want the gold and the copper, I also want a pathfinder that I have inserted here, for instance, antimony. I could just go for the new column, and in this case, I would import a column from my data essay. So this is going to be the mainly way that we are going to import all the geochemical data. So now about the visualization. We have just seen here that we can visualize both of them separately. But if, for instance, you want to visualize if it is any kind of relationship between those two elements on the mineralization right here, how we could do that? We could just see the visualization of the other elements by the filter. So right here, we need to click on the make the line solid. So by clicking on making the line solid, we will have here a little radius apply to our drill hole. And we can change this line radius right here. So for instance, we are just going to change to 10 so we can see the change in the visualization. I'm just going to make this a little bit here. And what we are going to do now, we can see the radius of this changing by another number category. So what we can do, we can change the radial values. Right here on this window, we can also change the value of the radio. So right now, we are seeing with the colors right here, if we click on the legend, they are showing to us what is the highest grade in red and what are the lowest grades in blue. So if we want now to have the visualization also on the high areas, the red areas of copper, if I am able to see any kind of correlation with the high numbers of gold, I'm going just to insert right here on the fixed radius gold. So what that means? That means that I can see here the biggest radios are going to be about the biggest values of gold. So I can check right here. And also, if I want to, I can enable my filter. So the filter is going to take out from the scene, and we can see right here that we can select this date. So if, for instance, I want to select just what it's higher than 2, we can just set here 2 if we want, and we will be able to see here just the values from 2 to 3.22 from copper and attach it to the radial values of gold. So this right here is a great visualization already for us to understand how our data is spreaded. So this way right here, it's a way for us to check out two numbers and how they might be correlated. So if we want, you can try a little bit with the opposite. So we can see the gold displayed here and the radial values with the copper. And this way is also a way of analyzing our data. And another thing that is very interesting for us when we are talking about the numbers visualization, that are the traces and graphs. So I am just going to take out the visualization here. I'm not going to take it out from here, but if you have done, just drag and drop again, there is no problem, because now we are going to take a look on the traces and the graphs. So if we check out on the graphs, we have here also the representation of our numbers. So we can choose a little offset right here. And through this offset, we can see that now our data is a little bit separated from our traces, which represent our data. So what that means that by applying this little offset right here, we can visualize better our data. And why this is interesting for us? First of it, we can just, by this visualization, understand what is the lithology that it's comprehending our mineralization, and also the spots of mineralization. This right here had helped me for my career a lot of times to identify hydrothermal kind of scapes, mineralization scapes. Why? Because we can see sometimes a pattern of enhancing those kind of mineralization near to structural trends. So for instance, near a fault, near a fracture, near a joint, or something like this. So you can use it to analyze, to first analyze your data and already have a good understanding of what is happening on the underground. So this could be associated of any kind of category. So if you don't have lithologies, for instance, but you have soil colors, you can already attach the higher grades to a determined kind of soil color. So in this moment right here, what I wanted to show you, how we can compare this to the geology. So now we are just going to take out the visualization of the trace, but leaving the graph, and we are going to bring in the geology. We don't need to bring in all the geology. We just need to bring in the interval selection lithology. That is the one that we are using. So we are just going to drag it and drop it right here. So now that we are seeing our geology, what is the problem that we are seeing here, that we are just seeing the trace? Is that we have edited the color the last time and not input the visualization for everything. So let's just go to the editing color and visualize everything. Click on the OK, and we have this as cylinders, so we can take a better look on it. And here we have grabs the representation of gold. So if, for instance, we want to clamp some values, we know that the maximum right here is on 16, but way probably this is representing an outlier. We are going to check this later on our histogram. And just for instance, if I wanted to clip some values.
Um,
Sorry,
I don't know
Michael.
how long the Joel survey is going to take to approve that stuff. But if you could send that contract with everything, and then the other one that you've already sent, I've just gone through it again, and there's nothing in there to say that we can add in it.
Sorry, which part? The essay. Hello, Michael. It's just
Julia,
just to check.
Michael was on some call, some phone. So you can
Oh,
continue.
sorry.
Sorry.
Sorry. I thought it was about the essay file that he was not finding. So no problem. Sorry. So carrying on, we have here our data and our geology also attached. Our geology right here is the one that we have used to model. So we can just take a look right here on the legend if you want to refresh our memory too, and what we can do here to understand to what lithology this gold is more attached to. So this is a tryout for you to understand what you're going to do with your data once you receive it, to understand what is happening. And we are going to try this in several ways. So I'm going to show you the more basic kind of doing that by the visualization only, but afterwards we are going to explore a little bit the statistical tables that we have so we can get this information also from our statistical tables. But I just want to show you that this is pretty easy to do by visualizing too. So if by the moment you are modeling, you are constructing your project, you may not have all the answers. So you need to find out what are the clues that you have to carry on modeling. So right here, we have the clamp values on the numerical display range. And right here, we can, for instance, input a minimum of 2 for the gold. And this way, we would have all the values clamped to 2, from 2 to 16. And this way, we could also try out by editing the color, editing the visualization of our drill holes by taking out and checking in the places that have the most of the values for gold. So we can first try our vein right here and understand that this is attached to our vein. So this is a great moment for doing a slice because you can see that this visualization right here, it's going to be way easier for you if you can cross-sect this. So we are just going to input the looking, D, pressing the draw slicer line, and we are just going to separate this data and check out how this is attached to our vein model. So this is basically the visualization that we can get, the more basic visualization that we can get from the numerical model. And you can see that we already can get a lot of information from it. So now I just want to mention again, because we had mentioned about this on our first day when I was showing the topography, how we can change the colors to make categories. So we are going to try out this with our essays So I'm going to put in for visualization our essays again and taking out the graphs and the geology. So we are just checking our essays right here. And now what we can do with our essays. If you come right here on your essay and expand the select color map, you have two options here. You can edit your color map, and we are going to click on it. So by editing this color map that we have right here, we can already check something, our histogram. So right here in the most basic inputs that we already have the information of the histogram. So if, for instance, you are a geologist, you need to give a fast answer on the moment, and you need to know if you're already seeing outliers or not. You can input your information right here, correct the errors, and you can already see if you have big outliers or not. So right here, we can see that our limits is set to dynamic. So we are not getting all of our data. You could see right here that all of our data is from 0.01 because we have done this. The 0.01 was the number that we have called right here to be replaced on the gold when we were correcting the errors. So if we go back and open the fixed errors, we can come right here and see that we had replaced it with 0.01. So this is the lowest value for gold that we have. And just closing this again and coming back in here. And here we can see that the highest value that we have is 16.8. So how we could take a look here in our histogram, all the data. I don't want the limits dynamic. I want the limits, the real limits for me, the geologist, for you, the person that is handling the project, to understand if you have any outlier or not. So you are just going to untick the limits and set the limits from the data. And you are going to click on this, set limits from the data. So when we set the limits from the data, we can see that our 16.8 is a big outlier. We already have lack of beans right here around 6. So if we want to input a more feasible kind of limit right now, by this visualization right here, we would put something around 6. So I just want to show you this little option right here and how we can now visualize it. So if you want to see this histogram like the histogram of the log, we can just, by expanding the options, clicking on the histogram of the log. And then we can check out how our curve of frequency is behaving. And we can also change our curve points right here. So if we want to see a cumulative one, we could just see right here. And if we want to go back, we just need to untick everything. If you want to change the being wild, you can. So you just need to take out the automatic right here and write the being wild that you want. Remembering the being wild is the size of this column right here. So just to check everyone is with me. Do you have any doubts into this moment? So I suppose no. And we are just going to revert it and close it. Because now I wanted to show how we can make categories from it. Because as you can see, we have seen now the addition of a continuous color map. We need to check out how we could do a new color map that is on categories. So we can just click on new color map. And in this case, we are using the discrete one. So when we input the discrete one, we will also have our histogram right here. So we can change directly on the histogram, and this will change directly on our visualization. So if, for instance, I want to understand a little bit my data here, I could be selecting through here to understand the frequency of my data and which intervals are being the most important, which intervals I could consider as outliers. So right here, we could see that until 5, we still have some data, but from 5 to 6 on, the data is really scarce. And from 6 to 10 is getting scarcer. And if we talk about 12 and 16, we'll have probably just one, which means that we have an outlier right here. So if you want to already correct your gel database and go to search this outlier, you can. If you want just to make a notation for you and for your team that you have an outlier, you can come right here on your project tree and already do your notes. So you can just open the notes right here and start doing your notes for all your team to be able to understand the things that you are doing too. So if you want afterwards just to copy to clipboard or to cut to clipboard, you can also do that. And now that we have explored a little bit our discrete, we are just coming back to our normal continuous color map. Now on the discrete, I just want to show one thing extra. Here on the options, they are going to be exactly the same, but on the generations of the interval, we can also select the interval mode. So right here, we have the data, where it's from, and what is the range of this data. So if you want to change this, you just need to close and come back here to the x-axis limits. And then you can just choose here the interval mode that can be the quantile, progressive, progressive double, equal intervals, logarithmic intervals, and k-means clustering. That this is going to depend basically on the method that you are analyzing, if it's an XRF, if this is an essay that it's coming from ECPMS from the laboratory. It depends a lot on the type of method and the elements that you are seeing. So if, for instance, we are just looking for angles right here, it will be a different proposition of trying to separate an essay, for instance. So you just need to be aware of what you are trying to get right here. And the quantile, to be honest, is one that we cannot make a mistake. Is really is the basic of the statistics, and it's pretty good already for doing a primary separation, categorical separation. So if you don't have your cutoff yet, if you don't have a lot of informations of your deposits, this is a good way for you to categorize your data without too much effort. So if you want to do that with your topography, I'm just going to repeat that because this is an incredible way for you to also do your geotechnical domains if you need. So, for instance, we already have here our combined model that it's our open pits with our geology. So, if I already did some categories on my topography, separating angles of dip and strike, I could already insert the geotechnical domains also in my combined model. So I would just need to drag and drop my topography right here. And as you could see, we have already started to do that. So if you come right here for the elevation discrete, we can just click on the editing color map, and this right here is the limits that we have that is set from the data. And these limits right here, they are talking about elevation. So if we wanted to talk about dip and strike, we would have to select right here, face dip or dip azimuth. So this would depend on the geotechnical analysis that I wanted to do. But on the face dip, we have 0 until 90. So what we could do in this moment right here, we could go for the face dip, select it right here, face dip expanded, new color map, and this case is going to be a discrete because we are creating a new color map with discrete intervals, specifying the number of intervals to use to color your data, define the boundaries of those intervals, and select the colors to be used. So we have selected the discretes, and we could set the limits from the data and 0 until 90. This is a perfect way of the program telling me that everything is fine, because of course could only be from 0 to 90. And we can generate the intervals in the same way. So from 0 to 90, we could separate by quantile, and the number of intervals could be 5. And we could just apply it to check how it would. And this is the categories, the main categories that we would have. So if you want just to check out how this is, you just click on X on the window that was appearing. And if you want to add more categories, it's just by clicking on the plus right here. You don't need to generate the intervals automatically. You can just generate your own intervals if you prefer that. So right here, we have the intervals that can be done statistically or the intervals that can be done manually if you want to add more limits for your categorical data, your categories on your numerical data. So now that we have checked the easiest way to visualize your data, we are just going to take a look now on how we are going to prosecute on the numerical modeling. I'm just going to speak a little bit now about the process that we are going to describe it. That is going to be the backflagging. So the backflagging, it is basically the combining of the categorical and the numerical data. So often when we are exploring our data to understand the relationship between the lithologies and the mineralization, are given a specific physical property to be analyzed, a good way to determine, to verify those kind of relationships is by creating a table with both of them. So in our case, for instance, we already have created volumes and isosurfaces, right? Imagine that we want to now check our data related to the volumes that we had created. The process of doing that, of getting this data and these numbers in the same table, it's called backflagging. So this is basically the combination of this categorical and numerical data, and how we have already commented here. This could be different lithologies and mineralization. This can be a specific physical property either, or can be yes, a specific property um, for you would be the density, for instance. If you already have the information from density from specific lithologies, this would be a perfect way to input that, because we know to get our tonnage afterwards, we will need our density either. So now that we have already seen a little bit what is the what we are trying to do and what is the mean of black flagging, we are just going to practice a little bit, because we are going to create now an evaluation column, an evaluation table. So I hope that everybody is following up right now. We are going to clean our scene. So just cleaning the scene. And coming back to our project tree, now I'm going to ask you to collapse all the rows again, and we are just going to check our drill hole data, specifically our essay, because I am want to create right here for you an evaluated column. And how we are going to do that? We are just going to go for the essay. Oh, sorry. Now you must receive all the same kind of notification too. This is meaning your license has expired. I have already spoken about that yesterday. So we just need to click on the OK. You can see that right here, my connector is opening. I just need to go in the Get Started, open, and right here, we have our license already renewed for another 24 hours. So now that I have already renewed it, we are just coming back to our essays, because we are going to back flag one column. So what this means? That means that we can do that for just one column, or we can do that for a new table. So we are going to first do that for the new column. And in this case right here, we are just going to click on an evaluated column. You can see that right here, we can create also category from numeric, but we are going to check here the evaluated column. So you can see right here, the evaluated column that we are going to insert is the GM geology output. So what that means? That means that we are inserting right here the information that we have generated in our geological model. So this way I can have these categories in the same place as my numbers. So I have my essays. I wanted now to have this essay is from where, and this place is what kind of solid, what kind of lithology that I have inserted on the volume. So we are just going to input the column name as output and clicking on the OK. So now we have here our geology model output. We can insert here to take a look. Why? Because now we have an output on our essays that is showing category. So that means that right now, all the things that we were trying to see, to visualize, we can do that way easier, because now we had attached the columns of the numbers with the categories that we have already modeled. So we can see here the overburden, we can see here the vein, and we can see here the radial changed for the copper. So if we want it to be the gold, we just need to expand it and go for the gold. And on the gold, we could check that the line radius is pretty big on the vein, but it's also happening on the QZP. So probably on the QZP, if we further look on it, we would have some information of structural data that maybe could help us to understand how this mineralized gold is behaving. So here we have our first evaluated column. And now that we have checked our first evaluated column, we can go for our evaluated table. So if we are trying to do an evaluated table, we are going to go for the drill holes. And in this case, we are just going to go for new evaluation table. So just right click on the drill holes and go for new evaluation table. Now that we just need to click on it, and we are going to, on the table, what we are going to do is to select the model that we wanted to be evaluated, and we can expand here and see the geology model, the open pit, the weathering, or the static phase 1. And the column name that we are going to have in this table for this data right here, and the table name that is going to be GM Geology Evaluation. So now we just need to click on the OK and wait for the processing right here. So if you are waiting for the processing right here, always remember, if your processing is taking too long, just come and take a look if it's not paused or if it's not on priority only, and go for the run all. So now that we have already done our GM geology evaluation table, we can take a look on it. So if we visualize it, we are not going to see a lot of difference on it, but if we take a look right here, opening, we can see that we have here attached all the GM associated with the from to. So this is a way for us also to evaluate our how our model is behaving. Now I'm just going to close our table and to show the last option. Why? Why am I saying last option? Because if you could see right here, we have mainly three ways of backflagging. I have shown the way that we have of backflagging, doing a new column, a new evaluated column. We have done a new evaluated table, and the third way is using a merged table. And we are going to take a look right now. What is the merged table? The merged table, the same way you are going to create right here on the drill holes. And you are going to right click on it, and you are going to input the new merged table. Click on the new merged table. If you click on the new merged table, we can see that we could input the essays along with our GM geology evaluation. And this could be our merged table GM evaluation. And just click on the OK. This way, all the informations that we had right here, we will have right here with the informations from our drill hole. So if we just open it, we can take a look on the gold, copper, and on the GM geology. So if we want now to take a look on the statistics of it, we will have everything in the same place. Remembering, right now we are talking about a data set that is not making a lot of difference, the merger table, the evaluation table, and to input the evaluated column. But what that means? That means that if you are just trying to search for one parameter, just one column beside the others that you already have to evaluate, you are just going to click on New Evaluated Column. But if you want to statistically evaluate everything on your model, you are going to do a New Evaluated GM table. So, oh yes, to enlarge the screen of Leapfrog. It is on top already. It's fitting on my screen. Unfortunately, I can't make it way bigger. Maybe this way on the project tree. Uh, well, carry on here. So we have here our evaluated table. Sorry, because now it's a part that it's pretty nice and it's a part that it's important for us to understand. We are going to start to analyze our statistics. So how we are going to get our statistics and what is the options that we are going to have with it. We have already seen that we can take a look on the statistics only by visualizing right here and by editing. And now we are going to take a look how we are going to see the statistics attached to everything. So we just need to come to our merged table GM evaluation and right click on it. We will be able to see the statistics. So let's click on the statistics. And you can see that we have some options here. We have a table of statistics, we have a scatter plot, QQ plots, box plots, and interval length statistics. So if we are talking about box plots, QQ plots, and scatter plots, what those plots are? They are bivariates. So you need to compare one thing to other thing to make sense. And when we are talking about the table of statistics, this is not much different because on a table, you will have a bunch of domains. So we are just going to take a look right here on the box plots. So the first of it is going to be the box plot. That is basically a box plot of a single numeric column splitted by a category column. So what that means? Two variates. So we have opened the box plot right here. And what are our options? We can input here our numerical column, and we are just going to input gold. We are going to input here our category column, that it's going to be our GM geology output. And we could also input a query filter. This query filter, we are going to build one in the next steps, because at first, let's take a look on what we want to filter. If there is any boundary, any lithology that it's making sense for us to filter. And now for us to visualize this data, how we are going to do? We are going to click on the categories that we want to visualize. So we will need just to input our data right here. So by visualizing our box plot right here, what we can get from it? We can get that our vein is the one that contains the most of gold. So we could also change the minimum and maximum whiskers. Whiskers are those little bars of error. We can change the inner fences whiskers too, and we can change the outer fences whiskers and input this in a log scale if we want to. So now one thing that I wanted to mention, that this is the part why the query is important. You can see that the program can only evaluate all the data. So if I am taking out the vein right here, taking account that the count is not changing, the length is not changing, the mean is not changing. If I take out the granodiorite, still the same. So if we want to statistically have the weighted statistic, we will have to apply the filter for an specific lithology or a specific domain. It doesn't need to be a lithology. The filter can be any have already taken a look right here. Let's just see what we can see in our statisticals by the box plots. We can see the count, the length, the mean, the standard deviation, the covariance, the variance, the minimum, the first quartile, second and third. So if you want to have a pretty good view of your data at first sight, we can already, with the right click, go for the statistics. So if we already have this data right here, and if we want to export it, what would be our options? We have right here on the top, export the graph image. I'm going to click on it, and you can see that we can do that on a PDF format, as a vector, or as a PNG file. So if you want to input that on CorelDRAW or Inkscape to be able to get the information from the vector, you just need to output that as a scalable vector. So the other options that we have here is to copy the graphic image and to copy the statistics data. So if you want just to copy the statistics data, this is a place that you can do that. The statistics data are going to be this little box right here. And if you want to go for your table of statistics, you can just click on here. So right here, we have our statistics table, and we can take a look here on what we have on the count, length, mean, standard deviation, coefficient of variance, minimum, quartile, median, ultimate quartile, maximum. So if I want now to input also the copper, I would have it right here. And one part that is really important for us if we are statistically dealing with our data is to understand the interval length. Why? Because if we have irregular interval lengths and we are not taking into account the interval lengths to do our statistical analysis, we will not have a normalized data. If we don't have a normalized data, we can have a lot of problems of under and overestimation of our deposits. So it's very important for us to also analyze our interval right here and the stands and mean of it. So we are going to come back to analyze the interval and also to perform our query for our vein right here and analyze it statistically alone. And after that, we are going to jump into our numerical model. There is any questions until this point right here?
That is fine. Yeah. Julia, this query filter is it working? You see
Sorry?
the query filter. We will discuss this later.
Sorry, the query filter, you say?
Yep.
Yeah, the query filter right here, we are going to do after the interval.
After the as well. Okay. Okay. Okay.
So if there is No questions right here on the statistical part, and everybody's following up until this moment. We are going to take the 10 minutes break right now and be back
Thank you.
to, sorry,
Thank you. Thank you for the break.
no problem. So after the break, we will be back. If you need the project, if you are lost or something like this, just tell on the chat or something, and back in 10. Hello, everyone. So please tell me if you are already back, if you need a little extra time. We are going to jump in now to our query building. This is an important part, the query building, because this can avoid a lot of troubles for you on your further construct of your project. And why? Because the queries you can actually build almost anywhere. So I'm just going to show here in our project tree the places that you can find the possibility to build your query. So right here on your colors, if we check, we can build a new query filter. So if you want just to select some of your drill holes, you can just click on your new query filter, build it, and you just need to select the color. And for instance, if you are selecting a specific color ID, you can just input color ID, test equal, and the value. What we can do here, we can already do our query filter for our phases. So
Julia, you
if
have
you
shared
want,
the
for
screen? Have you shared the
sorry,
screen? The screen is not visible. Is it
what is
visible?
not visible? Sorry.
Yes, it is visual.
It's visible?
Yes,
Oh,
sir.
then it's not here. I don't know why.
Oh, the
Yeah,
screen that I'm sharing. Sorry, I will try to stop and share again. I will stop and sharing again. You're still having the same problem?
yeah, still not visible. Let me check.
Oh, sorry. There is anybody having the same problem too? Is possible to see my screen?
I can see.
I can see.
Okay, perfect. I could only I could also see that Babita had asked to enlarge the screen of Leapfrog, but unfortunately this is the larger. So I have my it's a really big screen that I have here, and it's full on Leapfrog. But please tell me if you're having visualization problems. Maybe tomorrow I can try to find out another way to share the screen too. So I will carry on a little bit here. And if you still having visualization problems, please tell me. Afterwards on the recording, I think you will be able to see everything without a problem. You will be able to see my screen too. So now coming back a little bit on the build of the query, because we are doing some test outs here to see the queries that we can build and how this could make your project more organized. You can find easier your domains, and also you can select easier what you are trying to see and analyze it. So right here, we had started by the color. I have right clicked on the color, new query filter, color ID right here, but I don't want the color ID. I want the color dot phase. So you can see that the first name right here is the file name. The second is the column name. So if we check right here, we have the file, color, and right here we have the column. So the column that we are reading is the phase, and we want is, and the value, it's going to be phase 1. And we are going to click in OK. And now we are just going to input the phase is phase 2. So we have how to input what is the phase 1 and the phase 2 right here on these queries. So if we want, for instance, to understand the difference, the phase 1 and phase 2, we can just input right here. So let's just click on the advanced On the advanced, we can also input our functions. So what they are going to mean. So phase 1 and phase 2, it means something. If it's phase 1 or phase 2 will mean another thing. So if we are putting one and the other, we are putting together the both of them. If we are putting one or the other one, we are selecting which one we want. So right here, we would actually input the OR and just do the OK, and we can input the name of this square filter as our face and just clicking on the OK. So right here, we have how to open again, apply it or not. So in our case right here, let's just check the phase 1. I just want to show you that it's possible to do. So we are just going to click right here, and we can see only our query for the phase 1. And if we want to take a look and do the other one for the phase 2, we can too. So now coming back to our essays, we are going to do that for our vein. So we have checked here on the statistics that we have a higher value for copper and gold on the vein and on the QZP. So we are going to build two query filters, one for the vein and one for the QZP. So how we are going to do that? To build this query filter, we are going to do that on the merge table GM evaluation. So we are going to right click on it and we are going to do a new query filter. So on the merge table GM evaluation, we are going to build a new query filter. So now that we have opened our little window, we can build the query. And what is going to be the column that we need to test? So remember what I have already spoken. On the first, we will have merge a table. And afterwards, we are going to have what we want to input the query. So we are willing to input in our GM geology output. So the merge table is, and in this case, we are trying to build for the vein. So we are just clicking on the OK, and the name, the query filter will be vein. And now we just need to click on the OK. Now that we have already done for the vein, let's do it for the QZP too. So this way we can compare the both of them. So we are going to right click on the merge table and do exactly the same process. We are going to open the window, build the query right here. And after building the query, we are just going to input the column that is going to be our merge table GM evaluation, GM geology output, test is, and the value this time is going to be our quartzite porphyry. So now just doing the OK, and we can click on the OK, and here just write the key Z and just doing the OK. So what that means? That means that now we can individually actually analyze what we are seeing. So if we click right here, on the statistics, we can already take a look on the box plot again. And this time we are going, please check out this table here and how it's going to change. I'm going to apply the query filter for our vein. So we could see right here that we had changed a lot of patterns right here because we have the mean, we have the standard deviation, we have the covariance right here, and now we could input to the QZP. So this way right here, we can individually analyze our domains and also compare them. So this one is a really nice tool, mostly for us to also make a boundary in our data, in our specific data that we want to start to refine, because this is basically what we are doing now. We have done the basic model, we have done the base of our project, and now we are getting more advanced on it. So we have here a little bit of our statistics, a little bit of our query. So now that we have already understood a little bit about the query, we have understood the evaluation and how we are going to connect all those data, so the numerical data and the categorical data, how this is going to make sense together. Now we need to enter in another subject. This subject is a little bit more complicated because it's compositing. So why am I saying this is complicated? It's just because of the first part of it, that is to understand why you are compositing. Because after you understand why this is necessary, it will be pretty easy to understand why this happens. So the compositing, the, the the data, when it's logged, uh, you already have some interval for it, but not all the intervals have the same length. When we are going to build a numerical model from this data without further processing, we are going to end up with points that have uneven data support. So for instance, we will have some place that will have the same value as other place, but this place doesn't have the amount of data as the other place has. And this can cause you a problem of underrating or overrating in some places. So what we are trying to do by compositing, we are trying to give equal weighting to points that would represent vastly different volumes of the rock. So because of it, we will compose it in order to normalize the volume of the rock being represented by a point. But, well, the intervals that have no data, they can have a significant effect when we are composing the data too. So this is why we also have done the steps on the error parts, that we are replacing the places that we don't have values by the limit of detection and not zero. Because when we are normalizing, for instance, interval that are missing data can be assigned a value of 0, which will be the same value that we would have assigned uh, for a non-numeric value, maybe. So that is important. That is the important part, why we should consider the instrumental error as the last, the bare minimum that we can detect. So now we just need to, I think that it's going to be a little bit easier for you to understand when I show this little picture right here. So when we are compositing, we are trying to make everything even. So to make everything even, what that means? That means that if I have, for instance, something that have 2 meters and the other part has 3 meters, and I have told that I want to composite in 2 meters, I will have 1 meter from this second one that has 3 meters that is going to be taken out. So what we do with this information that is being taken out, we can discard, we can append this to the previous interval, or we can distribute it equally. What that means? That means that the same way that you have something that was 3 meters and you have set the 2 meters, you may have something of 1 meter that will need to be fulfilled. So when we distribute it equally, we are distributing what is sparing for this 3 meter one through all of them. When we are appending just to the previous interval, that means that we are just going to use the rest of this data if the previous interval of this compositing is also missing a little bit of data to get into the 2 meters that we have settled in this example. So how we are going to establish this number? How can we establish a number of normalization? Well, this actually is going to be pretty easy if we are talking about the normal data that we have daily basis, because generally we take samples from meters. So if you have missing samples, or if you have a specific continuity to your drill hole meters of sample, you can use this number. But if not, we are going to use also the statistic table that we have just seen to determine this number. So we have our project right here. In our merged table, GM evaluation, we are just going to right click. And when we right click on it, we can see the statistics again. And in this case right here, we are going for the interval length statistics. So the interval length statistics is very important for us to make the determination of our compositing interval. So right here, we can see that our mean is almost 2. So what that means? That means that if we select some value that is near 2, it will probably already work. So on the filtering, we could input now the vein, that the mean of the vein is even closer to 2, and on the QZP, that we also have something close to 2. So we can input the number right here as 2 or 2.5 as you wanted, but the important part is to have this number on your mind because you are normalizing your data now. So just be aware of it. This part right here of the compositing, the normalizing, if you are not a great geologist, great resource modeling geologist, this is a part that you probably are not going to do that much, but it's very important for you to be aware because you will probably receive data normalized. So you need to understand how this is affecting your data. And of course, you can also use some really similar methods for geotechnicians, and also if you are trying to do a different kind of domaining. So now that we have seen a little bit that our magical number is going to be around 2, we can just take this step out because we are going now for the compositing. So let's come right here to our project tree and again collapse all the rows. And we are going for the drill hole data. So if you are trying to composite your drill hole data, be aware the compositing file, it's right here on the drill hole data. You just need to expand it and expand your drill hole data. You will be able to see the composites right here. So let's right click on the composites. We will have 4 options of composites. So the first of it is going to be a new category composite. As you can imagine, this is going to be exactly what I was telling, but for categories, not for numbers. We are interested right now in seeing this done for the numbers, but be aware that we can do this for the categories. The majority composite is very lookalike, but is taking the majority of it as the categorical one. So this one is going to be very interesting also if you have a lot of interbedded lithology that doesn't have a lot of physical difference. This way you can model way better and make domains, numerical domains that would make more sense and not be separated by tiny layers. Also, the economic composite. The economic composite is very interesting if you are trying to get a fast answer from your data. So I'm just going to click here before we go for the other, for the numerical composite, because I wanted to show you that this composite right here is basically binary. So in this economic composite, we are selecting what is the number of the cutoff and what is going to be the OR and what is not going to be the OR. So you are going to input the query filter that you want here, the numerical values that you want here, the fixed handling value, interval handling, if you want it, and also to fill the ends, to use the average of enclosing intervals, and also to cap higher grades. So the compositing right here will have more options, as we know. So that's the point that I'm saying, that if you are not a grade or statistical kind, a geostatistical kind of geoscientist that is going to deal with this data is not going to be very important. Why? Because these are the dilution rates and the rules that we need to apply when we are talking about the economic geology. So we will have the dilution rule right here, that will have the basic, the advanced, and the advanced plus. And if there is interest in this part right here, I can send an article afterwards. Is more, it's a little bit more advanced, but you can see that we can oral composite the length, use the true thickness of it, include maximum waste, include maximum consecutive waste, keep short higher grades, and using the compositing direction. Why? As I have explained it right here, we will have these three options to choose if we are cutting our intervals. And this is what we are going to be missing, and we need to decide where this is going to be. And to make this decision, we need to understand the direction of the composite. So if it's going down to the bottom, bottom to up, or if it's going both ways, and we are getting the disposal on the middle. So you can choose this, if it's down, if it's up, or if it's both. And you can also choose to composite it twice. The compositing twice is a very important tool also. It's going to make your data even more normalized. So if you are able to always composite twice, is going to be the best way for you to deal statistically with your data. So just remembering everything that I'm saying here about compositing is a normalization of the data. So now we are just closing the economic composite, because I just want to show you this is an easy way for you to separate what is ore and what is waste in your project. So if we want to do just a tryout here, separating on what is ore and what is waste, we could already have the volume of ore and waste, because we have already a combined model here. So we would already know the amount of ore that we had inside this pit, the volume of it, and the volume of waste that we will have to deal also. So pretty easy way to have already some answer for a very difficult question. So now that we are here, we have already seen the economic composite. We are going for our composite right now. That is going to be our new numeric composite. And what are what is our options right here? We have the option to do in the entire drill hole. So this is going to create intervals and apply composite parameters to all values down the lane of the drill hole. In a subset of colors, that is going to create intervals and set compositing parameters for each lithology color code and the intervals from the table. We are just going to use the subset of codes right here. So clicking on it, we can see that we have here the parameters that we had checked right here. So what that means, the action that we want to take on this specific lithology, and this action can be filter out, no compositing, or compositing. Here we have the length of our compositing. We know that the general length that we have here is 2. So on the default, when we change the default, that is this first line, we change everything that is down. So if our length is 2, maybe we can put 2.5, because 2.5, we would have 5 as the middle. Or we can input 4, but just pay attention that this number is important to be a good number to be divided. So in our case right here, I'm going to input 4 because this is going to be 2 plus 2. And the residual length is going to be 2. So if I have a residual length of 2, I want a minimal coverage of 50, right? 50%. So the residual handling, I can input on add to the previous interval or distribute equally or discard. I always prefer to add to the previous interval because this way, right here, we would have less trouble of making everything even when we have sometimes some kind of deposits that are not even and they must represent that. So we could insert an additional weighting column right here. So for instance, we are doing the compositing right here for our lithology output. We could insert it here, the other outputs that we will want. So for instance, we could insert the essay and we could insert the merge table evaluation. So in our case right here, we are just going to import the merge table evaluation because as you can see, the merge table, it's already merged. We have already fixed everything that is on there and we will not have a problem of missing intervals. And now we just need to click on the OK. And we can take a look on it. So we can just take our numerical composite and taking a look on it and realizing that now we have a more normalized data. So that means that our lithology and everything else is trying to follow a certain pattern. So now that we have already spoken a little bit about the compositing and the importance of it, we are going to jump into our numerical model. So let's clean everything and collapse our rows. So we have checked today already how we are going to visualize our numerical data to get information, how we are going to access our statistical tables and univariate and bivariate graphs, how we are going to select colors to make categories, how we are going to normalize our data, and how we are going to attach our categorical data with our numbers. And now we are going to jump in to the numerical modeling. So if you take a look on your project tree right here, we have our numerical models right here underneath the estimation. So if we right click on it, we will have here 4 options. So the new RBF interpolant is generally the numerical modeling that we use and the one that we are going to use today at first. The new multi-domained RBF interpolant is when you already have a multi-domained model. So if we have already in our geological model refined our model to do the domainings on our lithology, we could already use this one, but we are going to first use the new RBF interpolant to understand how this is distributed in our model. So we also have here the new distance function. So the new distance function is going to be basically a buffer. So if you want to have a notion, a 3D notion of a distance from a specific thing, a specific file that you have here, you will use the new distance function. So I'm just going to right click on it so you can take a look. We need to select the objects and we can select any object. We could right here select on the drill holes just the traces and we could click on the OK and we could input the distance to the traces and the boundary, no distance buffer boundary clipping, the trends that we want to do that, and the buffers that we are going to have around it. So we could set a buffer in a distance that would be a 25 meters distance and in a 15 meters distance. And I could click on the OK. And we will have our processment time right here. And after, we can just drag and drop. And here we have our buffer from our drill hole traces. And you can ask me why this is important. This is very important if you are planning new campaigns. Also, this can be very important talking about environments and several other things that we must to be aware of the distance that we are working from our platform of drill hole. So for instance, if you want to input the same thing on a water body that you have or on a river or in a place that you know that you cannot touch, this is a perfect way to doing the buffer that we can see on GYS here on Leapfrog. So this is going to be the main way for you to buffer something from a specific object on your on your project. So we have checked that the numerical models can be distance to trace, but what we are really interested here is to start to build our numerical model for gold. So we are going to build a new RBF interpolant. The numerical value right here is going to be gold. We are not going to change anything right here. The only thing that we are going to change is the existing model boundary or volume because we already have it from our geological model. So we are going to go for geological model and select our boundary and click on OK. And our surface resolution right here, we are going to leave 20. So the volumes enclosed, we could enclose to higher values, lower values, or intervals. In our case, we are just going to leave on the default that is going to be the intervals. If you want to composite right here, you could also input the compositing for the entire drill hole within a boundary. And here you have your name. So if you want to input also another interpolant boundary instead of this one, you could. So now that we have already inserted right here and we have our name, we just need to click on the OK. So this way we are going to have our first pass gold um, numerical isosurfaces. So now let's just click on the OK, and we can see the processment happening right here. So we have here our gold model, and now we just need to take a look in what we have available for us to also check out what we can change. So if you expand the gold numerical model, you will see the boundary, you will see the trends, which is very important. You will see the values of gold as points. You will see the isosurfaces, and the isosurfaces right here, they will make the same paper as the surfaces that we have created in our geological model. Our surface chronology right here, the surface that we have created for our category, here they are going to be the isosurfaces. So coming back to our gold model right here, we have our isosurfaces and we have our output volumes determined by those isosurfaces. So if you have 3 surfaces, you will have 4 volumes. So let's just pass a little bit through some golden rules that we can find for the numerical modeling. So just remembering the rules that we have spoken yesterday about the 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 general modeling too, they are also going to be applied right here. So when we are talking about the numerical modeling, we are just talking about a few more points that we should keep aware. So the first step would be to clean the drill hole data, removing the inconsistencies. So this is a time-consuming process, but it's important. Also, the second step is selecting the numerical values that apply to the values and the categories that you are using. So, for instance, the backflagging that we have preceded here was this step. The third step would be to apply a trend. If we know there is a trend there, we need to apply a trend to make it better. And the final step that is really important, that is to determine how the user surface is bounded and calculated for each place. So this is basically a few more reminders for us to be aware of the numbers that we are using and if we had understood clearly what they are pointing out to us. So now that we have here our numerical model done and we have expanded here a little bit, we are just going to drag and drop it right here. So what do we have? We have a really, really huge numerical modeling and really overestimated. And how we can say that? Because we have here a lot of gold values estimated for a place that we are not sure if they have really this amount of gold. So our model at this moment is a little bit overestimated, but we can see that for our first pass modeling is still pretty good. Why? If we go to look down and we do a slice on it, we can check out that mainly our higher grades, they are attached to our data. So what that means? That means that our grades are attached to our data. So this doesn't mean that the program is pretending new data, is just expanding the data that we have. So if we want just to go a little bit further with the slides, you already know we can go by right here and just keep taking a look inside of it to see if we find these big balls right here, because those little circles that are done around our essays, we can call it pair strings. So what that means, like a string made of pearls, we can see that along the traces of the drill hole data, we are seeing these circles of data. And this can be very interesting for you depending on the numerical data that you are seeing. If you don't want to be conservative and you want this all to be together, there are several ways to edit our model together. So this is our first pass. Now we are just going to clean our screen a little bit, and we can take a look by double clicking on what we can edit. So double clicking right here
Julia,
in our project. Oh, hello,
sorry,
Babita.
I'm interrupting you. I have a question. Can I ask?
Yeah, just tell me.
Yeah, in perspective of generative models, if there is a no Perl string, then how we are going to interpret this model?
If
There is a no Perl string as you shown us just now. If there is a no Perl string in my model, then how I am going to interpret it?
if there is no of those balls that I'm seeing here.
Yeah.
So no, just for you to mention, those strings, pearls is they are not. I'm just going to put down and put the slicer again. Why? Because you can see I am just going to put the traces because this way I think you will be able to understand perfectly what I'm saying. Because you can see right here
These
those
are
tiny
the,
balls.
these vertical lines are our drill hole.
Yes, this that they are along the traces of the drill hole. So this is not actually good for you, for your model. So what we are trying to get here is why this happens and how we can avoid this to happen or make it happen. And we are going to do that by the advanced editing. So when we double click right here, we will have a series of interpolants, trends, and outputs to choose. And by changing those outputs, you can see that those strings, they are going to go away or we are going to generate more of them. So this depends of the how much data do you have and how much conservative you are being. Because what that means? That means that the program is just doing a circle surrounding this essay, saying that there you have this volume, you have this ppm of gold. You don't have this for the rest of it. So what we need to do, we need to tell to the program that yes, it is correct. You can connect this information with that other information. But the only way that we can do that is by making the base range larger or smaller, changing the drift, the variance, the interpolants, the trends, the value transformation, the boundary, the compositing, and the outputs. They are the ISO values. And that's what we are going to do now on this next. I'm going to also give the break now because we are getting close to it. But after we come back from the break, we are going to take a look on all of those tabs right here and how we are going to make our numerical model close it and on the right place. Because we have seen right here that we also have this model, we can have this model constrained to the vein and to the porphyry quartz sites that we have, because this ore is inside those two lithologies. So we will also learn on the next steps how we are going to input this boundary. So this way we can have this constrained to what we want. So I hope I have started to answer you, Babita, because the actual answer we are going to give for the next 1 hour.
Yeah, it's still not
Because
clear.
there's
Perhaps in the after the break, when you are going to explain us on that time, it will be more clear.
yes, for sure. because as you could see, there are several things that are going to influence the spatial distribution of our numbers. So this is meaning basically that we need to change the spatial distribution of our numbers because this is getting too overestimated. But for our first pass, is not bad. So I'm going to give the interval. If you have any more questions, if you have any doubts, if you got stuck anywhere here, just tell me. And we are just coming back in 10 minutes. Actually, 14 minutes. So we can come back on the right time too. So if you have any doubts, just tell me. We are coming back soon. Anything, just tell me on the chat. Hello, hello, we are back. So, just to, my microphone is telling me right now that I am muted, but I am not sure.
You are
So,
audible.
you can hear me well?
Yeah, yeah.
Oh, okay. Thank you. Probably it's just a problem on the headphone that is always telling me that it's muted, and I am not sure if it is muted or not. But coming back now to our model. So we have seen now how we're going to build our first pass model. But after we done our first pass model, we need now to understand how we are going to make it better. This is too unrealistic, and now we need to understand how we are going to make it more realistic. So the first of it, you can see that we have surfaces right here. I'm going to make it clear again, and I'm going to input just the surfaces. So we can see one of the isosurfaces, and on this isosurface, that is meaning anything that is less than 1.11, these are surfaces they are going to be from 0 to 1. So you can see right here the tiny volumes that we have created. We can also check right here and right here. So these three isosurfaces, they are actually not making sense for us. So we are just going to build our own. So this way we can have a better separation for it. So we are just going to close it and learn where do we change those isosurfaces. So coming back to our numerical model, we can just double click on the gold, and then we will have here our table, our window. I'm going to expand it a little bit. And what the tabs that we have right here? We have the values, and this is the contour values that we can use. We have the compositing right here. So if we want to composite after, we can too. The best way for us to composite will be always attached to our data. And why? Because if we composite it right here, we may not use the same compositing structure for other compositings, and it's nice for us to have this control that we are using always the same compositing. But if you want to do a tryout, you can always do a compositing just on your numerical number to see if the things normalized make more sense. So coming back to the boundary right here, if we wanted to enclose an object, we could right here. And the value transformation. So this is the place where we are going to take a look in our data and what is not realistic on it. So we have checked that our numerical number is not realistic. Is okay, is respecting, but is not realistic, is overestimating our goals. So the first thing that we should pay attention is on the value clipping too. So I am just going to carry on here for the outputs, but afterwards we are going to come back for the histogram, because it's on the histogram that we will be able to understand what is happening to our data. And we can check the trends and see that we don't have any trend right here. And we know that this is not true because this data that we had is almost all attached to the vein and to the quartz porphyry. So what that means? That means that we have a direction. It's just that the program is not understanding this direction, and we need to input this trend. The interpolants, this is going to be our last part of changing, because here we will have the variance equal to the total CU. So the total CU is important to be equal to the variance. We can see right here that we already have a nugget effect calculation. So remember, the nugget effect is going to be basically 15% of the total CU. And we have here the base range and the drift. We are going to come back to this because it's a little bit more complex. So let's start with our outputs. We are seeing here our ISO
Uh,
values, and we want to
Julia,
change this surface.
you said
Tell me.
that nugget is like 50% of variance. So is it a thumb rule or is something like it varies?
Oh, I am just giving you this is was actually for gold. So if you see, I think there is some articles about it, how to
Mm-hmm.
calculate the nugget effect, but this is going to be specific for each commodity that you are
Mm-hmm.
searching. So
Okay.
I'm just applying the overall rules here, but the nugget
Okay.
effects, they are going to be actually calculated by you with your
Okay.
variance. But we can input the 15% as this is the general idea of the nugget effect.
Okay. Okay. Thank you.
But on statistics, this is something that I can send you some articles about it because
Yeah.
this is not very related to the workflow of the software. This is really
Yeah.
about geostatistics and geochemistry. But I can send you, anyways, some articles that I have for nugget effects and how they are more applied to polymetallic deposits.
Great. Thank you. Thank you. That will be great. Yeah.
You're welcome. So now coming back to our outputs, we will have the default resolution right here and the ISO values. So we are going to change a bit our ISO values. So this way they are going to make more sense. So we are going to input this from 0 to 15. Actually, we are going to be 25 from 25, beginning from the 5. So it's going to be 5. Here, I can input 75, and here I can input 1, 1.25, and 1.1. So we have here the, oh, sorry, this one had changed it, is 0.50. So we have here the 0.5, 0.75, 1, 1.25, 1.5. So we are going to input the default resolution as 10, just diminishing a little bit the default resolution. And now we have 1, 2, 3, 4, 5 ISO surfaces that are going to separate our volumes by 6. So
Julia,
now we just need to click, oh, tell me,
I have one question.
tell me.
How do we decide this resolution? Like sometimes you are putting 20, sometimes 10.
Yeah. So the resolution right here. What I wanted to show you is that it's important that when we are doing something that is more specific, we can change the resolution. And we are talking about here the general resolution of the geological model to each surface. So in the same way that on the geological model, we have also a specific, let me see if I can open here. We have here a specific resolution that is heritage from the geological model. We have the same thing right here. So if we come right here to our gold, the values right here, we would have to change the default resolution right here. So if we are now with this data that we have seen that our interval for the uh, our interval for the samples is 2 meters. So what that means? That means that our data can go into the minimum of 2 meters. So that means that the closest that I am from the resolution, the best will be the results that I can get. And what was the problem that we have with our first pass numerical model here? That this is not realistic. So we are
Okay.
trying to bring it to reality. So when we are inputting here a lower resolution, we are doing a tryout to bring this a little bit closer to our data reality. So we are going to change those factors a little bit more. This is just the first step, okay? So after doing
Okay.
this first step, we are going to the value transformation. After the value transformation, we are going to the interpolants. After the interpolants, we are going to check if we can already see any trends. So this right here is to show you that the numerical modeling, it's a process. It's not a long process. It's a very short process, but it's a process. You are going to first pass your model, analyze it. It's making sense. It's not making sense. If it is making sense, great. This means that you have to overlook this here and you will probably not change much, but you still will need to overlook it. So if it is close to the reality, great. That means that you will check here and see just some details. There will be the value transform and the interpolants and the trends. But if you're in this case right here, that we can see that this is way overestimates, we will need to check each one of them and probably redo it. So we can change the value transform and need to come back to check if this is better, if this is not better. So right here, what I'm trying to show is that you will have to pass through the process. It's not a hard process, but you need to understand what you are doing right here. So if your aim is to make it closer to the reality, in our case right here, changing the resolution, it's going to make a difference. If this wasn't my case, if was good, I would not change the resolution because it was already good. And also because this resolution here is not far away from my resolution here. So my contact right here, as we have seen, is on a 10 resolution because it's heritaging from the geological model. So this right here is respecting also the resolution of my lithologies. Remember, when you do a surface right here, for instance, an intrusion surface, I'm just going to open so you can take a look. On your surface resolution for the intrusion, only the intrusion surface is going to be half of the resolution of your geological model. So just to be clear here, the intrusion is going to have always a lower resolution, and that's why the surface of the intrusion is more robust to do some modelings if we are looking for a closed domain. Got it?
No, can you please explain this point again? I couldn't understand why half of the resolution.
Okay, so let me just think about how to explain this again.
Only the last part, like you have taken 5, so why?
So no, for instance, you have to think about what you are doing. So what you are trying to do here, what is our objective right here, is to make this more realistic, right?
Right.
So to be more realistic, we need to be closer to our data, right? So the resolution of our data is almost 2. We have seen that on the interval of statistics, right here on the geology evaluation, on the statistics, we can see that the interval is 2, not this one right here. Sorry, is not this one right here. So coming back here to the statistics, on the interval length of statistics, we can see that the mean is 2, right? So what this mean is saying is saying that we have our essays divided in 2 meters generally. So that means that the closest that we are to 2 meters, this is the best resolution that we will have. So if we have a very unrealistic model right here, and we have a 10 meters resolution right here in our geology model, to make our numerical model more realistic, the best for us will be to make the same resolution, right? So if we lower that resolution from 20 to 10, it will make it closer to our data. So this way, we can comprehend our data in a better way. So I am just going to make this happen, and you will see the difference that you will have between one model and the other one. So I'm just going to open this again. And here I will have to redo it, but it's no problem, just a few minutes, because we are going to change the default resolution for 10. And now that we have changed the default resolution, is going to change to all of them. And now here, we are just going to do from 0.25 to 0.5. And then we are going to have here the 75. And here, 1. Here, 1.25. These ISO values that I am inserting right here, they are a tryout. The resolution, of course, is the same as my geological model, but my ISO value, I am inserting this to do a first tryout. So if you are trying to do a first tryout, always try to put the difference of 0.25 between those
Julia,
ISO values.
this ISO values. Are these the value of gold in ppm? I mean, like from
No,
SA?
no,
No?
those are generated by the software. So they are a normalization of the data. So they
Okay.
are inputting the data from 0 to the maximum of data that you have inserted. In our case, we have from 0 until 16.4,
Mm-hmm.
which is the problem that we are going to see right now, that our problem is the outlier. But the thing is that these values right here, for instance, the 1.5 will comprehend until the maximum value. So
Okay.
this is the lowest value and this is the maximum value. And those are parameters. The ISO values are done from the software and they are not attached to the numerical values, just the separation of them. So if I have here a range that was from 0 to 4, it will be the same as a range from 0 to 16. So the ISO values, they are always done if you are trying to, for instance, if you have just one, you could insert here just one that is going to separate your data in half.
Okay. Okay. Understood. Thank you.
So I'm just going to make an annotation here to send the material for ISO values and the nugget effect. Because this way it's a little bit better if we go further on these subjects separately and carry on a little bit here. So now that I have done this, I just need to do the OK. So you can see that the limits right here, the minimum 0 and the maximum 16.8. What we have already checked, that the 16.8 is an outlier. We are going to take this out in the value transform clipping, but first let's do the OK. So now we are processing our model to check out if it's going to make sense, if it's going to make more sense, if it's going to make less sense, what we are going to get here. So what we have seen that now we have, oh, sorry, it's just the output volume here. So here we have our new ISO values and surfaces. So this is the highest value to go from the lowest values. So here we have the concentration of this high value, and we just need now to clean it all to bring the full model. And we could see that our model is getting better. What we are seeing right here, that everything that we had that was a little bit overestimated now is being compressed, being each way more compressed. And now we need to take a look on the other parameters so we can carry on editing. Why? Because we are in the right path. Because when you are seeing your numerical number, you have to analyze it. There is no way to do that without looking to your model and analyzing it. So you need to understand what you are seeing. If, for instance, you have your traces too separated from your estimation, like in this point that we are seeing right here, we know that this is overestimated. So if we want now to keep constraining it to make less overestimated, what we are going to do, we are going to carry on with our values clipping. So we are coming back here on the project tree to our numerical model. So right here, we are going to double click on it and go for the value transform. Why? Because we want to now eliminate this outlier. So we are going to click on do the pre-transforming clipping. Why? Because we want to understand right here the point where we don't have data anymore, where the data is scarce. So we can check right here that it's seeming that it's around 6. So if we want to do that, we would need now to input right here 6 and click any place around it, and we will have this a little bit more fitted. But now that the histogram has updated, 6 is still the value. You think that 6 that we have inputted here as the upper bound is the best value right now? Because we can see that the data is getting scarce actually on 4. So the actual upper bound right here is when we don't have more data. So changing here to 4, and now we can see that this is continuous, which will mean that my model right here would comprehend the right data. So now let's click on the OK, and let's wait for the processment. So now that we have changed the clipping values, we have here a better resolution, but it's still with a lot of the data distribution done on this side right here. So we can check right here that this is giving us a really high value in this moment. So what that means? That means that we have here a sector that it's already getting there when we are talking about the evaluation, but we still have a sector right here that has really higher grades. So we are going to carry on our editing. We are coming back on the gold right here, But on this case right now, we are going for the interpolants. So the value transformation right here is the one that we have just done. And now we are going for our transformation right on the interpolants. So the interpolants, this is a moment very important for us to pay attention, because when we are talking on this place right here, this can get a little bit trickier. Why? When we are talking about the interpolants can only be linear if we are talking about something that is not domained. So something that we want to understand the trend where this is going. This is not our case here. Why? Because we know the lithology that the gold essays are comprehended. We know that this is a polymetallic deposit. So what that means? That means that this is constrained, this is closed. And when it's closed, we will use the interpolants as if spheroidal. The total seal is going to be the same as the variance, and the base range. The base range is going to be the value that we are going to input, that is generally 2 or 2.5 times the distance between our data. So what am I going to do here? I am going to get my ruler and we will check our data and how far they are from each other. So I am just going to check it with my color because it's going to make easier. So I am cleaning everything out, going right here for my color. On my color, I am going to look down and I'm just going to take a look here on the distance. So my distance here is 50, which means that my base range right here, the ideal one would be around 150 to 200. I'm just going to insert 200 at first for you to take a look. And the drift right here, it's going to tell a little bit about this part of the curve. So if I change the drift to none or linear, we are going to change this part of the curve right here. You could see that the 200 was inputted on the distance right now, and this is the interpolant that we are getting. Now this is a spheroidal one because we know that this is a polymetallic place. So now we just need to click on the OK. Wait a little bit for the processment. And bring on our model. So what we could see now, we could see that now it's constrained to what I want. Now it's making sense with what I have. And now I can understand why my data was being expanded that much. Because I have a high value right here. So the program was getting together this data with this data right here because of my base range value. So right here, my base range value was too big and the data was being connected in places that it shouldn't. So if we start to diminish this value right here, we will start to getting more of those circles, those tiny purse strings. We are going to make them, make more of them and make those circles a little bit more conservative. The last is the base range right here. So I think that we had a question right now about the purse strings also and how we are going to interact with it. And this is going to be the mainly way that you are going to correct or taking out your per strings. Is going to be basically by changing the base range, the drift, the interpolants, the variance, and the total seal. But remember, the variance is going to be totally um, commanded by your value transformation. Why? If we change the data that we are analyzing, for sure we are changing the variogram of it. So now that we have it right here, our first pass model already done, we can now constrain it to our models. Why? Because we already have right here some of the boundaries that we need. So what we are going to do at this point, we are going to clear our scene and we are going to copy our model. So if you right click on your model, you can copy it. So we are going to copy it one time, and this copy is going to be the vein. And clicking on the OK, and we are going to copy it again because now it's going to be our QPZ. So it's going to be gold QPZ to do the analysis and do the OK. So if we check right now, our models are the same because I had just copied. But what I am willing to do right here is to give a boundary. Why? Because we have already separated our two, we have already done our two filters, and we want to have this for our, we want to separate it for our little model right here. So how we are going to do? We are going to go for the boundary, enclose object, and in this case, we are going for our geology. And right now on the geology, just be aware to get the right surface chronology. So on the geology, oh, sorry, it's not here. Sorry. We are just going to constrain it to the gold vein and to the QPZ right here. So carry on a little bit with our copper QPZ and our vein QPZ. I just want to be sure, actually, before moving on, that because we have some questions right here, and I know that this part of the editing can be very concerning, but it's important for us to understand what we can already get from this volume that we had created right here. So if you check out on your project, you can open the statistics or you can open the properties. If you open the properties, it will open this little window for you right here, and you can see the properties and go directly for the statistics, or if you just call for the statistics, it's going to open the statistics. So we see here the history, the processing, and the general of our project. This is very important. Why? Because here on the general part, we have the value clipping that we had used. We have the interpolants, the alpha, the range, the seal, the nuggets, and the drift that we had used. So you don't need to actually keep coming back to your data to understand what had been used right here. So now we just need to close it because we have here also the global trends and the global mean. We just need to close it. And now I just want to ask you one more time, do we have any doubts surrounding right here? Because I think that will be good for us to have a little break right now, although it's not the rounded hour still, but I think it will be good for us because this way you can think a little bit on the doubts that you may have now for the last parts. I know that this is a part right here that is a little bit tricky because we need to go back and forward, back and forward. And this is the normal process of learning. I know that in the first sights it can be a little confusing, but you will see that after doing some projects, doing that by yourself, you will see that in 1 week you will be a pro. And also that any of those things that I'm saying are very hard. And one of the last things that I wanted to mention also, it's because I don't know if I made it very clear, but in all of the points, we had our interrogation point. So for instance, if you are not understanding something on your interpolant, let's click right here and see what we are going to have from our data set of informations. So right here we have our output settings and we have this article already mentioning everything that I have spoken a little bit here. So also we have here uh, the screenshots showing you a little bit what they are talking about, the interpolant functions. They are talking a little bit about the ISO values too. And this right here, it's very important for us to have easily because this way you can understand the things that you need to understand at the moment. So, for instance, we were asking right now about the nuggets. We can just come right here and see how the nugget effect is calculated right here for us. So, the nugget effect to total seal ratio, the base range that I have just spoken, right here we can have the alpha too, because if you have not noticed, we have an alpha number that is always settled. And
Julia,
also we have here, oh, sorry?
this that base range we are talking about. You told us that
Yes,
we kept base range of 200 because this has to be 2 to 2.5 times of the distance between the boreholes, drill holes, right? And now,
I'm sorry. I am finding very hard to understand because my headset is pretty bad. I am
yeah,
pretty sorry about that. I have my volume at the top at the moment.
yeah, yeah,
But could you repeat?
I'm saying that the base range that we kept 200, that is because it has to be 2 to 2.5 times between the distance of collar, right?
Yes.
Now, since we have kept base range 200, it has come down the volume. And now if we keep it 100 and if we keep it 50, so if I keep 100, it will be underestimated, and if I keep 50, it will not estimate. Is it like that?
Yes, exactly. And I can
Okay.
even show you by doing that pretty fast right here so it can make more clear to everyone. We are going to change the base range again to see what happens. Just the base range. I'm not going to change
Hmm.
anything else, just the base range. And we will see what happens. Because when we open right here, go into the interpolants, I am going to input here a base range of 100 and you will
Hmm.
see what happens. We are going to have volumes a little bit underestimated. Not exactly underestimated in our case right here, but
More
it can be a
conservative.
little bit underestimated because it's too close to the samples. So you are not
Yes.
making things continuous. So I am inputting the base range here to 100 and putting OK. So for us to check a little bit what is going to happen, the processment time is going to increase also because we are talking about things that are tinier. So you could see right here that I have little volumes inside my bigger volumes
Mhm.
that I didn't have before. So if I do the slicing right here, we could see that I have really tiny volumes now. So this sample right here was classified as one and only and was totally separated by a circle because we are now underestimating our deposit.
Yeah.
So I think now it's more clear, right?
Yes. Yeah. Yeah.
The base I know that it's kind of hard to understand at first sight too, but we are going to get there. I'm just going to come back here to 200 on my project. If you have changed it, also do that. And here the processing. And now when we come back from our little break, we will constrain everything to our boundaries from the QZP and the vein. Also, when we are carry on today, I want to get to the block models with you, but let's see how this is going to go. Anyways, we still have our last day tomorrow, so no worries about that. We can redo the schedule of tomorrow. And any more doubts, just tell me, okay? We are going to take a 10-minute break now.
Thanks. Thanks.
Hello, hello. We are back now. So we have already checked a bit our model and the things that will be attached to it, that we can change it to make our model more comprehensive, if it's making sense or not making sense. And now we are just going to clear our scene and collapse our project tree because we are coming back for our numerical model constrained to our quartzite porphyry. So we are going to check the boundary of it. We are going to expand it and right click on it, new lateral extend, and this new lateral extend is going to come from surface. So on your lateral extend, you are just going to get right here on the geology, the output volume for the QZP. So after you do that, you just need to click on the OK. And now we will have everything being processed right here. And last, let's see how it's modeled. So we can see now constrained to our lithological body that we know that is the one that has a little bit of gold. So what that means right here, that means that we already have domains here. Why? Because we already have some spots right here that we have a higher grade of it. And we can better analyze this because we have already done the geological modeling. So what I wanted to show you right here is the workflow too. So just refreshing the memory. We start by inputting the data, correcting the errors, grouping, doing interval selection, and doing everything that we need to prepare this data to start to be modeled. When we start to model it, we need to take care with the surfaces that we are creating if they are realistic with our data. After doing the geological modeling, we can attach all the numbers that we have. So if we want to do the geological modeling and attach these numerical numbers, this is exactly the workflow that we are going to get. If we, for instance, don't have that much information from geology or from the lithology, we are going to use a lot of the interpretations that we are getting from the numbers to do our modulation too. And we are doing that by the visualization tools that I had shown you today on the first things of the day, the first part of the training. So if we wanted to check if this was correlated to some specific domain or phases or lithology or color in our model, we could done that too by the visualizations on a data drill hole. So now that we have here done for the QPZ, we can do that for the vein. So now going for the vein, we are going to expand it. On the boundary, we are going to right click on it. And by right clicking on it, we are going to input a new lateral extend. This new lateral extend, it's going to come from surface. So we just need to create it from the surface. And as we know, the surface that we are using is the geology surface that is constraining our vein. And why we are selecting the vein and the QPZ? Because we had checked already in our backflatted table in the statistics that this is the place where we have all the R that we are looking for. So now we just need to click on the OK. And we will have this evaluated. So now that we have already done, let's check out. We are just going to make our scene clear and coming back here with our vein. So when we check our vein, we can see that this data right here attached to the vein, it's not good. So we will need now to do the same process that we have already done on the on our numerical model now to this specific base range right here. So just to check out, we have done the boundary for the vein and constrained the volume to the vein. Let's take a look on the QZP again. So checking out the QZP, what do we have here? We have something that is already okay for what we are trying to do, right? Now we are going to do the same thing for our vein right here. So let's clear. Just to be sure you are all following, it's making sense to you. You were able to get to the same place as me until this moment?
Yeah, yeah. We are trying actually. Yeah.
No?
Yeah, we are trying.
Yeah? Okay. No, it was just to check. Thank you very much. So now that we have it here on the vein, let's now start to take a look on what we are able to do right here. So we are going to double click on the vein. And right here, we are going to take a look on what we got. So we have here the output with our default resolution. We have here the evaluation limits, and we have here the value transform. The value transform is exactly where we have inserted on. So if we want, we can just undo it and take a look again. But yes, this is in the place that we want to, from the 0.02 to the upper bound, that is the 4. The trend that we still don't have much acknowledgement of the trend, we can leave this way. The interpolant, we can take out the interpolant right here is the part that we should take a look. Why? Because we could see that the variance had changed. So this is going to make already a difference for us. So in this place right here, we are just going to input the variance as 1.41. So right here, the base range. Let's take a look if this base range constrained to this volume right here is making sense. And how we are going to do that? We are going to do that by checking our traces again. So we can go and input our traces, because this way we can check on this surface if we have a base range that is getting bigger or not. Why? Because you can see that on the same place we have more than one drilling. So in this right here, in this surface that we are seeing right here, we are taking this in account too. So if we take this right here, we can take a look and see that the distance right here, it's 74. So we have actually a little bit more data right here, but not actually the, oh, sorry, we have actually more data right here in this place, but we actually almost don't have data right there. So the model, it's being a little bit extrapolated right here. So let's
Julia,
diminish.
sorry,
Oh,
I'm
tell me,
interrupting.
Papita.
There are a couple of drill holes. Those are hanging in a air, I think. Why? These are the data that error we did not able to correct. Those are the drill holes.
I can go at the sea.
Sorry, the data of the drill holes. So those drill holes here, they are not
No,
touching.
there are some drill holes. Those are out of the interface of the model, and they are hanging in air, not penetrating through the surface.
Oh, no, because this is the vein. This is not the surface.
Yeah, I'm sorry, that vein. That is not like OL026.
So this is the surface. I have inserted now the topography. This is the surface. We can see that they are all in the surface
Okay,
and
now I got it.
penetrating.
Those drill holes have not hit the veins. I got it. Thank you.
No problem. So this can be a little bit confusing when we are doing a 3D modeling. So now that you have mentioned it, I can show you a way that you can also verify this on a 2D. Because sometimes we know that can be a little bit harsh for us geologists to always think everything on 3D. And those things can be a little bit harsh to understand. So how can we know that this is touching or not my volume right here from the vein? I can check this by doing a drill hole correlation. So I am just going to right click right here and we are going to do a new correlation. So I am just going to show you a little bit. When you click to do this new correlation set, you will have this tab open. And on this tab, the first one that you can see right here is to select the color or the drill holes in the 3D scene. So we are going to select it. To select it, we are going to look down and I'm just going to select a few of them so you can check how we can correlate it. So I am just taking out here some things and I'm going to do the correlation between this. Oh, sorry. So I just need to click on down again and select my data. So you can see right here that I have a little number 1 here, a little number 2 here. So what that means? That means that the first one selected was this, the second one selected was this one. I can go here and take it out if I don't want it. And I can come here and bring it in. If I want to select them all at the same time, what could I do? I can select right here. So we can check that this was selected by a specific order and had not included the ones that are not touching the, the, the vein right here, but this is already going to be a good correlation for you to check out. So if we are here, we just need now to save this correlation. And now we can take a look on it to see if they are actually making sense with the data. So once we have this right here, we have selected on the image just the traces. So what am I comparing here is not the geology, it's just the traces. So if I want to do this correlation set, I could done for the geology. And this way, we would have here in the correlation set a little bit of what we want to see. So right here, we can input the source column as the geology output and click on the OK. So the interpretation table right here, it's not being able to upload because of my hardware. I'm sorry, I'm trying full acceleration right here, but you can see that this is a little bit too much for my tiny hardware. But right here, you would be able to check already your correlation being done. So I am going to send also an article showing a little bit this correlation, and also you can export it. So I am going to talk about this correlation tomorrow again. I just want to tell you that there is a possibility for you to see the things that are not touching each other, because this sometimes is a little bit hard for us to understand on a 3D view. But now I think it was pretty clear that those drill holes right here, they are attached to the topography, because right there I was constraining my data not to my topography, but to my veins. So now that we have already done it, let's clean it all, because we still have a few minutes today that I wanted to get to our block model, because this way we can talk a little bit further about tomorrow and what do you want to talk about again, because tomorrow we will have 1 hour just to talk about the things that we have seen and the things that you may have doubt, and also to see with you if you prefer to do a project that is based on historical data, or if you prefer to carry on doing the edge extension too. So now I just need to close it again. I'm really sorry, I am receiving a call that I need to take. Is just 1 second. I'm sorry. Hello, hello. I'm really sorry. This was a support call that it was really necessary to just tell that I could be there in half hour. So coming back here to our project, we are going to go for our block models now. So if you right click on it, we can see that we have the possibility to import a block model or to do from the scratch our block model. So let's take a look a little bit on what we were doing and what we have in our data sets. We are coming back here for our file and coming back here for our output interoperability. Why? Because we have here a little bit more of the phases that we could insert on it, and also I wanted to check if we have more informations to input in our block model. But since we don't have it, we are going just to perform a new block model. If you want to import a block model, you can do that by a .csv file or .mdl file. So after we have checked that, to construct our block model, we are going to click on New Block Model. And now it's a very important part where we are going to decide which block model we are going to use. As I have already commented with you, I was going to tell you the places that we are going to enter on Edge. So today we had entered on Edge when we talk about the advanced editings. So all the advanced editings that we have done, they are also the Edge part. Right here, what is the Edge part? If you just have the geo, you will have the option to do a regular block model. With the edge extension, we will have another 3 options. And you can see what is the option that is going to make the most sense for you. So if you are not remembering what they mean, where you can find more information, right here on the interrogation points that we have right here. So you can see everything that you can do with your block model. You can see all the evaluations that you can get from it, and what is most important of it, decide which one is going to fit the best for you. So personally speaking about it, the octree subblocked model and the fully subblocked model, they are very look-alike. And if you prefer to have this divided by the categories, the octree subblocked model will be the best fitting, because this way you can choose um, the domains and the categories that you would prefer to have is subblocked. So right here, the fully subblocked model, it's going to fully subblock it each time that you get close to a place that you need more detailing. So for instance, imagine that you have a 10 to 10 to 10 meters block. And on this block, you have this block on a vein that has actually 12 meters of thickness. That means that you will have 2 meters of this vein that is not going to be taken in account. How we can take this in account when we are doing our resource modeling if we sub-block it. So that's the reason why we have the sub-blocking on the edge extension too. And what we are going to do now is to try a full sub-blocked model to see what we can get. So what is important for us to understand when we are constructing our first block model? That we will have here the parent block size and the sub-block count. And you will have the minimum size here on the last line. So the parent block, we are going to input here as 15. Would you understand now that what the minimum size is going to mean? Because when we change to 50, we could realize that the parent block size divided by the sub-blocked count, it's the one that is going to give you the minimum size of it. So if you want a minimum size of 10, what you're going to do, change the sub-blocking account. Remember, the sub-blocking of the octree, it's going to be by pairs. So if you are thinking about inserting any kind of number here, it would be best to be on pairs if you don't want to have any break number. So we are going to input 100, and the extents we have here to enclose the object, and we can input to enclose our geology, our boundary, and just input the OK if we want. And then we can go for the triggers and evaluations. What do we want in our block model right here? So we want to have as a trigger our geology, but we could just input as a parent block centroid or a sub-block centroid. What is a trigger? The trigger, it means that every time that it comes close to a surface here, is going to be triggered to sub-block more blocks until get into the minimum size that we have inserted here, that is 10. So our block model can be here, our parent block can be divided in 5 until you get to the minimum size of it. I am just going to start by just inputting the geology, because this way I think is going to be a little bit better, the visualization, and then we can go a little bit further on it. And here is the proportion of it. So we have inserted the grid of it, the triggers and evaluations of it, and we don't have any proportions to follow in this moment. So we are just going to click on the OK. We will have here the processing, the blocking, the sub-blocking. It will be the processment that will take a little bit longer to be done. And why? Because you are using all the data that you have done so far. We are going to open really quickly the relationship right here. So on our block model, let's just right click on it and we can check right here, view relationships. So we have here the output that is from the GM geology. That means that everything that was used to build the GM geology was also used to build the block model here. So if we change things right here, that means that our block model is going to be just the grid. So you will have the block model, the full blockage, but you will not have the sub-blockage because you don't have any category or anything to trigger that. So now that we have it, I'm just going to close and we are going to drag and drop it to our scene. Why? Because I wanted to show you what that means. So we have checked it right here and what we can already get from it. We can already get that this sub-blocking is not good for us. We need a better sub-blocking because the lithology that was one of the most important for us was not being sub-blocked enough. And how do we know that? If you want to check, you can just come right here and do it by seeing the size of it and how it's not working in our project. And of course, if you want to, you can also, oh, sorry. So just inserting the block model again. So if you want to, you can just come right here on this tiny little window and try to set the filters for you to better look your block model. So how you can do that? You can select the index filter right here and just input the two options. At first, let's see the subset. So the subset, when we change it fully. So this is a way to slice your block model. And on the slicing, that you are just going to move in one direction each time. So if you move a little bit here, if you move a little bit here, if you move a little bit here, you will see that it's this block that it's taking. So just to show the options that we have right here on the block model, we still don't have inserted any kind of numerical number right here in our block model. We have just input the geology. So right here, we still don't have anything to do with the numbers and with the calculations, but we will have right now once we insert this data on the evaluations. So what that means? That means that for you to have an evaluation, and if we right click here to trigger and evaluate, to be able to have statistics, to interrogate your estimator, to do a new grade tonnage graph, to do a new report or a new sweat plot, we will need to do the evaluation on our specific category or a specific number that we are willing to do. So I just want this right now to be a little bit more um, detailed because we could see that this is not working for us. We will need things more detailed. And how do we know that? We know because right here, we were in need of input the data into 10 meters. So we can get here to the minimum size of 10 meters. So what we could do here, we could still diminish this part right here. So the parent block size can be a little smaller. We are going to insert now 20, and the resolution that we had, for instance, for the intrusion, it was 5. So this is going to be exactly the same size of the surface of the intrusion, the same resolution actually. And now we can just give the OK and wait a bit for the processment time. As I have already mentioned, the processment time on block modelings can be a little bit more challenging. So we can see right here that we have a way better visualization now. So changing our parameters was fundamental to have a proper view right here. So we are able to understand a little bit better how our vein is actually behaving. Here we can see the separation between the two dikes that we have right here, and also our porphyr. If we take a look and try to slice it, we are going to see how they are behaving. So we have here now our block model already on the points that we need. So it's sub-blocked to what we want, and it's making sense with our data, considering the resolution that we have used to do the geological model. So now that we have this sub-blocked model done, we can start to actually operate with it, trying to input what is important for us. So now on the block model, we can open the triggers and evaluations, and we can input here our gold QPZ, our vein, and the gold in general. So we can take a look on it too. So when we do that, just remember that you are having a little bit extra processment time. And now let's just take a look in what we have for our gold QZP. So if you take a look on it, we have now everything more detailed. And we can check right here that we can subset it, and we can also enable a filter. So on this filter right here, we can take off some parts of the sub-blocking. So we have the gold here separated from 0.01 into 2. And we can filter this amount of gold. So if you want just to filter your higher grades, we can do that. If you want to filter the lowest, you can do that. So for instance, imagine that you want the values from 1, yes, from 1 to 1.8. Those would be your blocks right here. And you can separate that on the window right here. This is the easiest way to do that. Of course, we can also enter on the block modeling on the trigger evaluations and proportions to check if we have here the numerical model that we want. And we can go for the calculations and filters and reporting. So calculations and filters, if we open it, this is the place that we will be able to calculate everything that is necessary for us. So if we have something right here that we want to do a calculation, so for instance, if we want just to catch some specific parts and we want this calculated, this is going to be the window that we are going to use for it. So right here is the place that you are going to create a new item right here is the place that you are going to copy items to another object, and here is the place that you are going to import items from a file. So for instance, you will need just to click right here, and you would have to select the item type. So it could be a variable, a numerical calculation, a category calculation, a date calculation. For instance, if you want to have just the samples that you get from the phase 2, we could get it. The timestamp calculation, or just a filter. If you want just to apply a filter right here, you can too. So this is a perfect place for you to do the things that you will need. For instance, if we are talking about specific parameter, this is going to be the place for you. But the part that is the easiest and the best one, it's going to be our new grade tonnage graph. So if we click on it, we can see that we can input some query filter on it. Also, the density can be constant, or we can change the density. So we can input the density based on the model that we done for the density, or the data that we have for the density. But if we don't have it, we can just leave constant. And here we are going to change the density unity. We can display the total tonnage as percent. We can apply additional units. We can change the grade units too, so it doesn't have to be grams per tonnage, can be ppm, can be ppb, percent, os, and of course, you can input your cutoff limits on the ZX and on the rest of your report. And the curves, you are going to make them by applying right here your curve, and you can input the name, you can input the grades, and you can input the unity right here. And this is the tonnage that we are going to have. The cutoff grade that was calculated for here, it would be really near 0.5 for us, and considering our gold consider our gold data right here. So now that we have already get to the report that was the most important for us, we can now go a little back, and I can ask you, what do you think that would be the most interesting for tomorrow? So you want to carry on talking about the Oliver project that we have done so far, or can we move on to another project?
Is it possible, Julia, that we make a model through a geological map?
For sure, we can do that.
I mean,
So
like
this is the first option. Sorry.
actually, we were working on some project uh, for a gold exploration part. So we have got some map. So is it possible to use that data, or we have to use your data, something like that?
So we have to use my data, but
Okay.
this is just because of the agreements that we have
Okay.
done.
Okay.
Because
Understood.
if you want me to use your data, we just need to settle this with Cheho again,
Okay.
because we would just need to write a confidentiality agreement
Okay. No,
for
no, it's
that.
fine. Then we can use your data. No
Julia,
problem.
Tell me.
Julia, hi. In that case, can you just explain us how to make a model using the geology map only with the if any map you have like in using your data itself?
No problem. I'm going to show here what we can do, and it's going to be exactly what you're saying. We have already, oh, sorry, I have opened the wrong one. This is the advanced training. We are on the Geo Fundamentals one. 1 second. Right here in our course data, we have here also in the shell fonts, building a model from a map. So right here, we will have a structural data
Mhm.
and a geological map. And this geological map right here is not georeferenced. it doesn't have any information besides the image. And we can transform this in a 3D model. So we can do
So you
that
will
tomorrow.
explain this?
Yeah,
Okay.
Yes, for sure.
Yes.
yeah,
Thank you
that
so
will be
much.
great. Thanks. Yeah.
And one more
So
thing I
this is
wanted to
going,
ask you,
tell me.
like you have showed us, suppose we have some other software's model, I mean, if it is Datamine or Vulkan or Serpec, and we want to import it into Leapfrog, and like we have sub-blocked model or maybe a regularized model. So how to import it? Can you explain that as well?
Of course. So on your, you have to see on Datamine or Serpec, but you can export this as a .csv file. So you are going to import right here. On the block models, you can right click on it and you can import a model. So you can click right here on import a model, and we can see that we have two formats that are valid right here. Is the .csv and .mdl. So what that means that when you are exporting from Serpec or from Datamine, you just need to be aware to export on those formats right here. It's I know that it's totally possible to export on .csv. It's just the .mdl that I'm not sure which one was the softwares that were able to export on MDL, but you can do that.
Okay. No, I was asking about importing the model in Leapfrog.
Oh, sorry, I think I didn't get right. So you want this to be exported to Datamine and Serpec.
No, no, no. I wanted to understand how to import some other software's model in Leapfrog.
Yeah, but it imports. You are talking about block model or any kind of
Yes,
3D
yes,
model?
block model. Block model.
Yeah, is this way that I was. Are you being able to
Okay.
see my screen?
Yes, I was able to see. Okay, I understand. I understood. So for that we need that like XYZ sub-blocking numbers and parent block cell size, all these things, right?
When you export this from Serpec and from Datamine, you will have these informations already.
Yes,
So you have already made this decision on Datamine and on Serpec. So when you are
yes.
importing, you will not have to make those decisions again. Of course, that you can
Okay,
change it, but you don't
okay, okay.
have to. So
Okay, got
you
it.
can, but you don't have to. That
Okay.
the only thing that you may be very aware is that you will have to export on CSV or MDL format.
Yes, got it. Got it. Thank you.
Got it. You're welcome. So yes, tomorrow we will carry on just a bit, just a bit on this project right here, just to finish, to be sure that we don't have any questions anymore about it. And we are going to start our Sigan Valley model that is going to be done totally without any drill hole information. It's a pretty cool project also because we can speak about the structural trends there. So um, if you don't have any more questions, I know that it was a lot of information today either, but uh, we are getting now to the ending. If you have any questions, any doubts, or any suggestion for tomorrow, just please do it. And if not, I'm going to tell
Tomorrow,
me.
are we going to do the edge as well or no?
So I am not sure if you will have time for everything. Today we have already mentioned several parts of Edge, but we didn't have enter and ordinary kriging. If you want, I can just mention this right here on the estimation, new domain estimation. We can already start to talk a little bit about it. You can input the compositing right here, but we are really on time. I don't think it's going to be best for us. That's why tomorrow we are going to start with the Oliver. We are going to talk about the first hour of the edge extension on this model. Afterwards, we are going to have 3 hours to do the Valley modeling. This is a modeling that is done in 3 hours in general. So it will not be a problem to do that. It's just that the final hour of Q&A session that we would have, it would be taken by this, but I don't think it will be any problem for you because you could gain a lot of information this way too. So what do you think?
Yeah, okay. Yeah. And
Yeah, I'm also fine by that. Fine
Julia,
with it.
is it possible to send yesterday's recording and today's recording after this session? After this
Yes, I
session,
will
because
try
I'm
my
I'm
best.
I'm running behind because yesterday I couldn't attend your session. So yesterday training I completely missed it. So with everyone pace, I would like to move. So if it is possible, please send yesterday's recording after this
For
session.
sure.
Yeah, thank you.
Yes, for sure. I will try my best to be able to upload everything, but I will be honest, this is a little bit out of my control because it's really heavy. So we have a really, really heavy recording, and to do the download and the uploading again is taking me a while. So I am as I have already spoken, I am a geologist on the CSS team of Sequence. This is just one part of my day. So leaving the training, I also have to do the other tasks of support and the other trainings about the other solutions of Sequence. So sometimes can be a little bit challenging to give things from one day to the other already, but I will try my best to leave it uploading during the night because this way, for sure, by the morning, I will be able to send
Actually,
everything.
yesterday session I couldn't attend, and this training is little bit faster for me. I don't know about other person, but for me it's a little faster. If you will send yesterday video, that will be I will appreciate it because some part I completely missed it.
Okay, okay, no problem.
Thank you, Julia.
You're welcome. So I think that will be all for today. I hope that you had enjoyed it. And just one suggestion that I would leave for you, maybe it would be way better to have the remote training if you could let your camera open too, because this way I can see you, I can understand if you are already on or if you're not, because sometimes this way I don't have that much feedback. So I can start to talking and divagating a little bit. It's just that the camera can gives us a little bit of this proximity. So awesome. Thank you very much. Well, we'll see you tomorrow and carry on talking about our little model and starting by the edge, going after for the Siegen Valley model. Okay? Bye bye. See you tomorrow.